Let's solve this optimization problem from the Berkeley Math Tournament 2018. So we have here the triangle XYZ inscribed in the unit square ABCD, where AX equals BY equals CZ, and the area of the triangle XYZ is fixed at 1/3 square units. Now we have to find the maximum value of the ratio XB over AX. Alright, let's start by representing AX, BY, and CZ by M, since their lengths are equal. So this is M, and this is also M. Now, since the square has an area of 1, which follows from the fact that it's a unit square, its side length is 1, right? So we can represent XB, YC, and ZD by 1 minus M. Okay, so from these representations, we can write XB over AX as 1 minus M divided by M. So it's very clear from this equation that we can only maximize XB over AX if we minimize M. So how can we do this? I'll utilize the trapezoid BCZX. But first, let's notice that trapezoid BCZX has an equal area with DAXZ. Okay, so the area of BCZX is equal to the area of DAXZ. This is because their corresponding bases are of equal lengths and their altitudes are also equal. Okay, in particular, AX is equal to CZ and XB is equal to ZD. Okay, take note, AD is equal to BC, so their altitudes are equal as well. Now, because the area of the square is 1, each of these trapezoids has an area of 1/2. Okay, now we can also write the area of trapezoid BCZX in another way. In particular, I can just add up the areas of the 3 triangles. Okay, so we have the area of BCZX is equal to 1/3 plus the area or the areas of the 2 green triangles. But take note that these green triangles have the same areas, right? Because they have the same base and altitude or height. So I can just have 2 times 1/2 times M times 1 minus M. Okay, so if you simplify this, we get BC ZX equals 1/3 plus M minus M squared. Okay, let's equate 1/2 to this expression because they are representing the same area. So we obtain 1/2 equals 1/3 plus M minus M squared. So this quadratic equation will give us 2 possible values of M, and we will get the smaller of these 2 possible values because we want to minimize M in order to maximize XB over XA. Okay, let's gather all terms in the left hand side. So we have M squared minus M plus 1/2 minus 1/3 equals 0. To get rid of the denominators, I'll multiply both sides by 6. Okay, so we have 6M squared minus 6M plus 3 minus 2 equals 0. Or simply 6M squared minus 6M plus 1 equals 0. I'll just use the quadratic formula to solve for m. So we have m equals the negative of negative 6 plus minus the square root of negative 6 squared minus 4 times 6 times 1 divided by 2 times 6. Simplifying, we obtain positive 6 plus minus the square root of, this is 36, and then this is 24, so 36 minus 24, that's 12, divided by 12. Okay, so this is equal to what? 6 plus minus 2 square root of 3, all divided by 12. Or, this is the same thing as 6 over 12 plus minus 2 over 12, the square root of 3. So if we simplify this further, we get 1 half plus minus 1 over 6 square root of 3. Okay, so we take the smaller value of m, okay? So the smaller value is just what? 1 half minus 1/6 square root of 3. Okay, now let's go back to the expression we want to maximize. It's xb over ax, which is equal to 1 minus m over m. So we have xb over ax, which is just equal to 1 minus m over m. Now let's substitute m. So if you substitute uh, this value of m in the numerator, we'll just get, I'll just simplify it directly. We'll just get 1 half plus 1/6 square root of 3 divided by 1 half minus 1/6 square root of 3. Okay, so before I rationalize, I'll get rid first of the denominators. Take note that this expression is the same thing as this expression times 6 over 6. Okay? Because 6 over 6 is just 1. So this is equal to 3 plus square root of 3 divided by 3 minus square root of 3. Okay? So now, I will rationalize the denominator. So xb over ax is the same thing as 3 plus square root of 3 over 3 minus square root of 3 times. So I'll have here 3 plus square root of 3 over 3 plus square root of 3. So if we expand this one, we will have 9 plus 6 square root of 3 plus 3 divided by 9 minus 3. Okay, so let's simplify this further. So we have 12 plus 6 square root of 3 divided by 6. Okay, so dividing the top expression by 6, we finally get 2 plus the square root of 3. And so this is the maximum value of xb over ax.